Hello learners, welcome to the channel for the AICTE IDEA Lab at Oriental Institute of Science and Technology, Bhopal. Today's session is on 3D printing. 3D printing is not a new technology, however, it has become extremely popular lately due to the advent of sophisticated and easy to use 3D printers and modern CAD tools that are available nowadays. Initially, 3D printing was only used for prototyping and one-off manufacturing. However, it is now rapidly transforming into a production technology in the current times. And that is why it has been used as an extremely important technology in the AICTE IDEA Fab Labs. This is a brief initial intro for a quick start into 3D printing. At the end of this tutorial, the learner will achieve the following learning outcomes. The learner will be able to explain the basic concept of how a 3D printer works and its application areas, apply the online tools and resources for a quick start into 3D printing, choose and differentiate between the proprietary and the free software utilized in 3D CAD design and printing, print a 3D printable model using splicer software like Cura, and analyze the different types of print settings in splicing software for different print qualities. So let's start the session. What actually is 3D printing? As per definition, 3D printing or additive manufacturing is a process of making three-dimensional solid objects from a digital file, that is a 3D model using a specialized hardware known as a 3D printer. The creation of a 3D printed object is done through an additive process by laying down successive layers of materials. This, in a way, is the converse of subtractive manufacturing, which involves cutting out or removing out the material for creation of new objects. The best part about 3D printing is that it allows us to produce complex shapes which are difficult to achieve using traditional methods. Although it was only suitable for prototyping and still is, as we are using it for the same in the IDEA Fab Labs. However, it is also being rapidly used as a production technology by the industry by using big robotic industrial printers like as being used in the automotive industry. The market of a commercial 3D printing is expected to show a lot of rise in the near future as per predictions. So it all sounds like a very complicated thing, and as a beginner, where should we start? To see 3D printing in action, all we need is a 3D model, and that we can create one either from scratch or maybe download it from a 3D library. The latter option being the best option to make a start, as lots of ready-to-print 3D models can be downloaded from these online 3D libraries. My personal pick is Thingiverse, which gives you the option of downloading as well as visualizing the model in 3D all for free. You can either print them as they are or pull them into a 3D modeling software, which we will discuss later in this video, and tinker them to create new products. The links to these online resources have also been given in the details section, so do let us know if you have some more repositories in the comment section. Before get to the print or tinker with the downloaded 3D model, we need to know some of the basics of the software that we will be needing. The software that we need can be classified primarily into two categories. One, the 3D designing software, which you may not need if you're printing the downloaded model as it is, but you will need it if you want to make changes to the downloaded model. The second one is a machine interface software known as the slicer, which we will discuss in the latter part of this video. Now let's first get to know some of the best 3D design softwares that are available. I have classified them as beginner and pro tools. For beginners, I would suggest the best tool to venture into 3D printing is Tinkercad, and the best professional tools that I would suggest would be Fusion 360 and SolidWorks. Fusion 360 is also from Autodesk and can be obtained with a 1-year educator's license for free from the Autodesk website. So let us have a very quick and basic intro of Tinkercad, as much as we might be needing. Tinkercad is also a pretty comprehensive tool, and we will be uploading a detailed video for 3D modeling using Tinkercad. As of now, let's just get to know the basics of it. So let's first log on to tinkercad.com, as it's a cloud-based platform. After registration of the Autodesk account as an educator, you can log into your educator's account, which gives you the option of creating classes as well, or you just log in as a student account from your social login. I have logged in with my educator's account. This is the basic educator's dashboard, and you'll see a pretty similar one with the students' dashboard as well, with the exception of a few lesser things. It has a comprehensive library of inbuilt resources, tutorials and projects, which can be very helpful and exciting for beginners. So now let's go to 3D designs to see the basic designing interface of Tinkercad. As you can see that it has a very easy to use drag and drop kind of environment, which makes 3D designing for beginners enjoyable, as it can be very intimidating if we start off our journey with professional tools like Fusion 360 or SolidWorks. It also has a lot of primitives, that is pre-designed shapes, which can be pulled into the 3D plane to create new and exciting designs real quick and easy. One can easily tinker with the dimensions, add new objects, hollow out surfaces, and do many other things, and then export the designs as 3D printable STL, that is the standard tessellation language files. However, as I've said before, the tool is optimized for an easy entry into 3D modeling, and for more complex designs, you'll be needing more professional tools like Fusion 360 or SolidWorks, or maybe some other pro tools. Fusion 360 as a pro tool is my personal pick, as it has got wonderful capabilities. It's an all-in-one solution for design and engineering and manufacturing. It features tools for CAD modeling, simulation, collaboration, rendering and CAM programming. It can be used to design intricate shapes and mechanical assemblies, as well as to create very detailed drawings and 3D models. One of the most significant benefits of Autodesk Fusion 360 is its simulation and analysis tools, included with the simulation extension. SolidWorks is also a tool with similar capabilities for comprehensive and professional 3D modeling and design. We'll soon be uploading a separate tutorial for professional 3D designs using Fusion and SolidWorks. Now that we have a 3D model that has been downloaded either from any of the online sources, or a model that has been created using Tinkercad or any other Pro Tools, we'll be having an STL file by now, the most popular format for 3D printing. In a nutshell, an STL file stores information about 3D models. This format describes the surface geometry of a three-dimensional object. However, it contains a lot of 3D data, and for machine to be able to print it, it requires a sequential iterative input in form of a sequence of commands termed as G-code or machine code, which the CNC controller or the 3D printer can understand. So this is done with the help of a machine interfacing software, also known as slicers. The name itself suggesting slicing the complicated 3D model into layers for a sequential iterative input to the machine. Like 3D design software, many options are available in slicers as well. The most popular one being Cura, which is a free and open source software with even the source code freely available on GitHub. Most of the other machine specific slicers have been made using the source code of Cura. So now let's get to know Cura a little bit more. For this, I'm pulling the box and the lid model which I downloaded from Thingiverse into the Cura environment. So here I have imported the model from my downloads. We can use the plus and the minus keys to zoom in and out. Also, we can rotate the view using the left and right arrow keys. The perspective view can be changed using the view options in the bottom left, or by using the up and down arrow keys. The toolbars that have been given on the left hand side allow us to perform some basic print time changes, like moving the object on the platform and placing the design on the platform, scaling the design, rotating the design, mirroring the design, So it supports a very large number of printers, and we need to choose and add the printer before we can proceed with the print. As in my case, I've chosen the Creality Ender 6 printer. We can change the print material as well, as it supports almost all materials and multiple nozzle sizes for the print extruder. We have as of now used a 0.4 mm 240-degree nozzle attached to the extruder, which can be changed based on the material and its melting temperature. Now coming to the print settings, it allows for multiple print qualities which are dependent on multiple settings, but primarily on layer thickness. The finer the layer, the higher the print quality, and likewise it requires greater print times. There are lots of settings which I'll explain afterwards, but if we are just giving a demo print, I'll suggest using the recommended settings options first. Slide the infill to 20 and check support and adhesion. We'll discuss these options in detail afterwards when we'll see the custom settings. As of now, just hit slice to create the machine code and a simulation of our 3D print stages. As it shows that it requires 2 hours 6 minutes for our print and almost 13 grams of material. Before saving it to the removable disk, let's see the simulation preview. Here we can see the simulation layer wise as to how the printer will go about successively printing the layers of our job. Now let us explore the custom settings for a higher print quality. The first one is the layer height, and as conveyed before, the finer the layer, the higher the quality of the print. However, we can change the initial layer height to a higher thickness so that we can ensure better adhesion to build plate in the initial stages of the print. Wall thickness can also allow for adjusting vertical wall thickness and number of line counts for the wall. Now, infill. Infill is also one of the most important settings which affects the strength as well as print times, and in fact material usage as well. Infill density normally can be set between 0 to 100. 0 infill density will produce a hollow shell, while 100% density forms a solid block. Normally, we use an infill density somewhere between 15 to 30 for basic prints, but again that is dependent on the type of strength one needs for the design. So infill can look cool, add strength, save money, all depends on the print. Different types of patterns can work well on different infill densities with different kinds of strength. Typically with imprints of 0 to 15 infill density, we use the lightning, lines or zigzag infill patterns as they are the best because they give the fastest prints. Material temperatures are also normally set by the machine. However, we can change the temperatures here as well. The print speed settings is also a very important deciding factor in the quality of the print. A good print speed for 3D printing ranges from 40 mm per second to 100 mm per second, with 60 mm per second being the most recommended one and the default one. We can test print speed by printing a speed lower to see the effect of different speeds on quality. We can also vary the print speeds for initial layers by lowering them to 70% of normal print speed to get better adhesion and quality, and can increase it up to 100 to 115 mm per second for higher layers. However, we need to decide this based on the precision and finesse required for the particular part. By default, the infill speed is set to the same as the print speed, but one can make it faster in most cases. We can make it faster because the infill isn't visible in the end and doesn't require that flawless precision. By default, the wall speed is set to half the print speed. If the print speed is set to 50 mm per second, the wall speed generally will be set at 25 mm per second. The other settings of consequence are the support. which is to be enabled if the design has protruding parts which need support in the build plate adhesion, which allows us to form a layer of material beneath the model. Typically what I prefer is the raft option, as it provides proper adhesion because it forms a layer beneath the model. In addition to all these settings, one can enable the advanced and expert modes as well, which will further open advanced settings to fine-tune the prints even more. We'll soon be making a separate video on all the advanced print settings in Cura and other popular slicer software as well. Well, now that we know the basic things about 3D printing, let us print the design of the box and the lid using the Creality Ender 6 printer that we have in our IDEA Fablab. Most of the printers have almost similar sort of displays and controls, however, some may differ. We recommend reading the machine manual before changing these values and operating the machine. So now let's have a demonstration of our print and let's start the 3D printing now. So if you have any comments or queries, please do reach out to us at AICTE-OIST IDEA LAB @gmail.com or idealab@oriental.ac.in. Looking forward to meeting all learners in the upcoming videos as well.